Alright, this video is going to be talking about an angle addition postulate. So what happens if we add two angles together or combine two angles? What happens? Well, if we combine two angles together, we get a bigger angle. So just like that segment addition postulate, we can start to figure out missing things. If we know the size of the bigger one, we can figure out the smaller pieces. So to start off, I'm going to draw a line. We could use our inductive reasoning, right? We know that a line equals 180 degrees. So any two angles that help create this line, right? This total right here goes all the way from this side over to that side. That's 180 degrees. So if I cut that straight angle in some fashion, it doesn't have to be in half, it could be at any point, then I know that whatever this is plus whatever that is has to add up or has to combine to make 180 degrees. So let's say we know y. Let's say that y, we measured it and it was 50 degrees. Well, if I know that this much is 50 degrees, then this has to take me from 50 up to 180. So whatever I need to get from 50 to 180 degrees is what x equals. So I could say that x plus y equals 180. And I could say that I know y, and x plus 50 then is still 180. And I could use my algebra here to figure out to isolate x and get it by itself. In order to do that, I need to undo an addition or undo adding 50 by taking 50 away. We always keep our equations balanced, right? Both sides, we got to do the same thing to both sides. So let's take away 50 from both sides. That gets rid of that. That cancels. And we're left with x is 100 and... why are we not writing? There we go. 130 degrees. Now, I could also think about this slightly differently here. Let me get my eraser out. I could say, I could just use my algebra here and simplify this and say what x is. Well, I would have to subtract y from both sides, right, to get x by itself. So x is 180 minus y. If I knew what y was, I could figure out x. I could also, over here on this side, solve instead for y. So if I have x plus y equals 180, and I want to solve for y and get y by itself, I would have to take away that positive x from both sides, right? Cancel it from there. And get y equals 180 minus x. So now I have a formula that will give me y if I know x, and I have a formula that will give me x if I know what y is. All I got to do is subtract what I know from 180. Well, let's apply that to what we just did here. If I know that y is 50, well then x is 180 minus 50, and x would then be 130. And likewise, let's say I knew x. Now let's say that x I knew was 130 to begin with, and I didn't know y. Well, then I would use my y formula, and I would say y is 180 minus x, which I said was 130, and therefore I get y is 50 degrees. If I ever need to check any of these, well, I could add them together. Y was 50 and x was 130, so if I add them together, I should get 180. And yeah, they do add up, and it checks. And I'm right. So there's the basics of angle addition. Remember, just a little review here, that two angles that add up to 180 degrees are also called supplementary angles. Supplementary angles add up to 180 degrees. So anytime I have two angles that I know create a straight angle or add up to 180 degrees or are a linear pair, I can use this sort of method and figure out the missing one. Let's look at a different example here. Let's say that I have perpendicular lines. Remember that perpendicular lines intersect each other at exactly 90 degrees, and we symbolize the 90 degrees by drawing the little square in the corner. So this is 90 degrees. Okay, well, if I know that I have two lines that are perpendicular, they create not just one 90 degree, but really four 90-degree angles. Each corner here is 90 degrees. That's the definition of perpendicular lines. So now I have, instead of a supplementary pair, if you remember, now I have a complementary pair of angles. If I draw an angle right here, let me erase that. Let's be a little neater here. So if I break up that 90 in any way here, it doesn't have to be evenly. Ew, that's all kinds of garbage. Try that one more time here. Alright, there we go. So if I break up that 90 degrees into two different angles, doesn't matter if it's even or not, and I call this one X and I call this one Y, I don't know yet how I broke that angle up. I could say that I know because I have two lines creating a perpendicular intersection, I know that X and Y has to add up to 90 degrees. This has to be a total of 90 degrees here. And I can use my algebra here to solve for each one. If I subtract Y from both sides, then I get X equals 90 minus Y, right? That's X. And likewise, I could do the opposite. Let's redraw it here. I could subtract X from both sides. That would cancel that, right? And I would be left with Y equals 90 minus X. So it doesn't matter which one I now have two formulas for each one. Let's say that we know that Y is 30 degrees. Well, I need X, so I want to use my formula that gives me what X is. X equals 90 minus Y, and I know that Y is 30, so 90 minus 30 instead. So 90 minus 30 is 60. So X is 60 degrees. Now let's say that I didn't know Y, but I knew X instead. X was 60 degrees. Well, I would plug that in for this X over here and solve for Y. So I know that Y is 90 minus whatever X is. Well, X was 60. Sorry. We know that now. So Y is 30. And I can check it. 60 plus 30 does in fact equal 90. So yeah, these two angles together combine or add together to give me a total of 90 degrees. Checks out. So that is the angle addition postulate for both supplementary pairs and complementary pairs. Doesn't matter how we break it up.